Hi. So today we will be discussing about neonatal hearing screening. This is a part of our advanced neural science for engineers course. And what do you mean by neonatal hearing screening? First of all, what do you mean by hearing screening, right? So hearing screening means if person can hear or not. To screen the person, that means to not really diagnose, but to make an attempt whether a person is able to hear, process the signal, or it does not look like. Now, there are very standard procedure to do so, and this is done by applying stimulus to the ear and corresponding change in the EEG signals are observed from the scalp of your head. So, you have frontal electrodes, you have prefrontal, frontal, right central, occipital, temporal, parietal, as we have seen in the last few lectures. So, the ABR, which is called auditory brain response or brainstem response, is a far fetched signal. That means that it is almost we can measure from any part of the head, but the easiest way would be through the here, right, forehead. Why? There is no hair here, it is easier, correct. And the system that is used to screen neonatal or neonates is called BERA. This system costs somewhere around 14 to 15 lakh, and most of our primary centers, in fact 99 percentile of our primary center does not have BERA. Now, this is as per the literature, right. If some primary centers has it, is good, but most of them do not have it, and so is the situation with our secondary health center. But the tertiary clinics, they have it. Okay. Indira Gandhi hospital, they have it. Most of the hospitals in and around this city would probably have it. Tertiary clinics has it. Now, to perform the screening also, you require a technician, a personnel, a skilled personnel, and to have this kind of system in every village is kind of very difficult, but it is important. Why it is important? Because if you do not screen the baby, if you do not screen when the baby is born, which we call neonate, then only when they are 2 to 3 to 4 years old, the parents would know that the baby cannot hear, and late intervention will affect not only the hearing, not only the speech, not only the brain activity, but overall performance of the child, because hearing is related to the speech development, hearing is developed to your brain development, cognition. So, screening at earlier stage is recommended. So, that is a problem. The problem is that we do not have a screening platform, affordable screening platform that can be used by semi skilled personnel in our villages or primary health centers. Now, if we have learned through this particular course and few earlier classes is a subset of this course, or in fact the part of this course about EEG, then we should be able to design a system that can be affordable, that can be easy to use and that can be used to screen those babies and thus help in early intervention if the neonate cannot hear. So, that is what is the topic for today. So, if you remember the procedure of EEG, we had a particular montages, right, how to place number of electrodes on 1020 system and number of electrodes were 21 electrodes linked to various ways, the ways are montages. And you definitely remember the front part, this part, right, nation, inion, right, frontal, prefrontal, frontal, central, parietal, occipital, alright, temporal, right, this much we understand. So, temporal T, parietal P, occipital O, frontal F, central C. And we also know that the even number of electrodes are at the right side, the odd number of electrodes are on the left side, the Z1 is center, Z or Z is in the center. So, if you see the screen, this is what we have learned, right, how to record the electroencephalogram. Now, we also know that the EEG is of microvolts range compared to your ECG which is of millivolt range, EMG millivolt range, EEG microvolts range, microvolts versus millivolts. So, do we require all these electrodes like 21 for neonatal hearing screening? The answer is no. That means we need to come up with a better technology, isn't it? This we have seen in the last class that if you have this 21 electrode, the advantage is that you are not missing any part of the brain, but it is bulkier, it is has to be used by skilled personnel, a lot of data acquisition will happen, you require a good understanding about the EEG signal, feature extractions, understanding the signatures of EEG and lot more, right. So, we do not want to go through this particular approach and that is why we will go through some other approaches. So, in terms of importance, right, this is one of the most important research that needs to be done so that we have a technology that can be used by a semi skilled personals like our ASHA workers and can be used to screen the babies in most of the primary health centers or even secondary health centers. So, hearing deficits is one of the most chronic sensory deficit at the birth. Okay. That is most important thing that you need to remember. If you see the screen, the prevalence of congenital bilateral permanent hearing loss is approximately 1 to 5 per 1000 live births. That is a huge number, because for out of every 1000 birth 1 to 5 babies will lose the hearing ability permanently, right, while 2 to 4 per 100, not even 1000 infants, right, which are admitted to neonatal intensive care unit or NICU. So, the neonate who are born and are kept in NICU, this number is even worst, 2 to 4 babies per 100 or 2 to 4 infants per 100. The earlier one was 1 to 5 per thousand normal in a healthy baby. The next is more than 80% of the hearing loss in children are congenital or acquired in neonatal period. So, if you screen those babies in an earlier uh, time, that means that during the after the birth, right, within first 3 days to 5 days, then lot of things would be solved. If there is a hearing loss, there can be intervention at right time. And it's just not that it will affect the speech and other things, but the evidence from both human and animal trials or studies clearly indicates that the central auditory pathways do not develop normally in the absence of sound stimulation. Sound stimulation, if you do not have sound stimulation, the auditory pathway will not develop normally. Is that also raised?
It's fully charged, sir.
Let me know when you are ready. So, what are the consequences of the hearing impairment? This includes the inability of interpret speech sound. This often produce a reduced ability to communicate. Because of that, there is a delay in language acquisition. There is disadvantage in terms of economic and educational advantages. There is a disadvantage because baby cannot hear, cannot communicate, right. Finally, there will be social isolation and mental health stigma, right. So, these are the 6 points, right, which are the consequences of neonatal hearing deficits. The second point to note is that out of hospital birth and lower follow up rates are still a challenge for many developing countries, decreasing the coverage of neonatal hearing screening, right. When the baby is born outside the hospital, right, and there are certain tests that has to be done, right, that can be done even if the baby is born out of the hospital, which is can be done if the follow up, that means that you can take the baby, your parents will take the baby to the hospital, let the test run through, and that will help at least in terms of neonatal hearing, right, deficits, to understand the deficits. Early detection and treatment of hearing impairment in infants has beneficial effect on language and speech sound acquisition, right. So, there is a advantage or benefits. So, how does it work, right. So, you have to have auditory stimuli generation, right. Now, you do not require all these things because these are not young adults or a fully grown humans, right. these are infants and not infants, actually the babies who are born within means after their birth, within 3-4 days of their birth we need to measure this. So, keeping all these things is cumbersome, is not advisable, and that is why we have to come with an alternative technology. Now, when we say we, are there anyone who has already thought about it? Yes, there are groups who has thought about it, and we will look into those, some of the products available, okay, or 1 or 2 products available. Now, what you do once you have this EEG signals acquired from the scalp, right, you have to go for signal conditioning and EEG acquisition. That signal conditioning is important because the raw signal would have lot of noise, and those noise can be filtered out using a particular filtering technique. Generally what we have learned in our undergrad is that there are low pass filter, high pass filter, band pass filter, band reject filter, or we can say notch filter. But what about Kalman filter, what about adaptive filters, right. So, look into those terms as well. And finally, after looking at the signals, right, we have to do the signal analysis, we can give the results. So, the project objectives is not to just develop a neonatal hearing screening device, but also to understand are there any other biomarkers that we can add to further improve the screening technique. And can we reduce the time that is taken by the current technology, right, significantly. So, for any system that you generally come across, there is a front end and there is a back end. And front end is a signal acquisition and wireless transmission. The back end system is wireless receiver, MATLAB based signal processing. We can use MATLAB, we can use other techniques as well, and then the decision and neurofeedback is depending, it is given back to the person. So, this is a flow diagram or flow diagram of neonatal hearing screening device. So, the design and develop NHS tool, right, this is what we will look into, and that is why I have written in terms of project and objectives. So, NHS tool using CAEP. What does CAEP means? CAEP means cortical auditory evoke potentials. And we come with a new term now, which you can see here, mismatch negativity or MMN, all right. So, we would like to replicate the ABR test, which is a gold standard for neonatal hearing screening, and we would like to validate it with the Brainstem evoke response audiometry, right, which is a BERA system. We also would be using violet denoising to improve the signal to noise ratio, and finally compare the device with the existing BERA system, and then followed by screening few babies, right, in different geometries or geographies, sorry, in different geographies. To start with, as I told you, we require ether clearance, right, human ether clearance to utilize the device on and by placing it on the neonatal head for improving the hearing screening. So, we have the ether clearance, so we are going to use this system. The advantages are non-invasive, high temporal resolution, do not require high trained mental health professionals, and that is why it is scalable across our country. Here in India, evaluates the entire auditory pathway, OE only cochlea, where ABR up to brainstem. So, that is another advantage that we want to put it further, because now we understand how the EEG looks like, is to not only look at the hair cell, which is outer hair cell from the outer ear, but also to look at the brainstem and also to further go and look at the auditory pathway, complete auditory pathway. So, like we discussed, OAE is nothing but autoacoustic emission, and it is the echo generated by hair cells in cochlea when presented to the auditory stimulus. So, the OAE reflects status of cochlear amplification in the auditory pathway, and the image that you see or the picture that you see is one such system which is from competitive devices. It is a Macchio Aeroscan and Opto port light. These are the devices used for autoacoustic emissions. The second and the most normally used system is the Bara system. And you can see here again from the same company we have MB11 Bara phone and Netus Algo 5, right. So, these are two different systems that are used currently, and the auditory brainstem response is a far field summed potential captured, as I told you earlier, right, which reflects the neuronal activities from cochlea to brainstem within first 10 milliseconds. Very important to look at the numbers. Okay. Typical ABR amplitude is between 0.1 microvolts to 1 microvolts. Normal ABR should reflect 7 peaks. Latencies and peak amplitudes are the feature for different interpretations. Example, wave 5 is used to determine hearing threshold detection. So, the ABR amplitude is 0.1 to 1, 0.1 microvolts to 1 volt, and as we see normal is 7 peaks and the time to capture the data is 10 milliseconds. And finally, the wave 5 is used to determine the hearing threshold. So, very important slide if you look into the gaps and solutions, right. What are the gaps? So, like I said that for the ABR we just look at first 10 milliseconds and that is it, but for your mismatch negativity we go from P1, N1, P2, N2. Okay. Now, what is the advantage? Because if you see when the stimulus is given, the process is it passes through cochlea, goes here and then superior olive, goes to inferior and then goes to your auditory thalamus. Here is processes. This is the path for the ABR. What we want to do is we also want to look at the P1, N1, P2, N2, because in that case it will reach further from, you are looking not just the half path of the auditory pathway, but from auditory thalamus it will further process down and it will reach the auditory cortex, right. It will reach to auditory cortex. That means that you are looking at the full signaling pathway, full auditory signaling pathway. In ABR, as we have seen, there are 7 peaks which are observed here, and peak 5 is the one which says that okay, it is the hearing peak. This is the illustration of OE and ABR. So, behavioral techniques to detect hearing loss usually give correct results in infants more than 6 months of age, right. So, behavioral technique is only useful when 6 months of age, not for neonates. That is one important thing to understand. The second thing is there are high chances of missing a neonate suffering from auditory neuropathy spectrum disorder, right. This is very important to understand, and currently there is no system to check the entire auditory pathway at the time of birth, right. Very few, in fact none are there who can who are claiming to, or which the devices which are claiming to perform the entire auditory pathway at the time of birth. Now, I told you a term called mismatch negativity, which is P1 N1 P2 N2. So, mismatch negativity is the only cognitive event related potential, and event related potentials are also called ERP, present at the time of birth. Okay. The mismatch negativity is the only valid biomarker of neuronal auditory processing at the time of birth. Only biomarker. The next thing is that the MMN is attention free, non invasive, cost effective and subject specific signature. So, from babies to babies, when one baby comes and you place the device, right, and the signals that you generate, and the second baby comes, the mismatch negativity values would be different. So, can mismatch negativity will be a brain biomarker to understand their neonatal hearing screening, right? That is our interest. So, mismatch negativity is attention free, non-invasive, cost effective, subject specific signatures. And the why it is useful for neonate, because the current leak will happen since the anterior frontally are open. This is the fundamental importance or fundamental important fundamental parameter for us to understand that when the babies are born, the bone is not completely fused, the skull, and that is why there is a current leak which will help us to measure the mismatch negativity. So, let us see this auditory stimuli generation in the bottom left of my slide, and this is the proposed solution. That means a person wearing the headband, and in this case we do not require many electrodes, we require only a few, and then the data acquisition system takes over, where you have signal acquisition and extent triggers insertions, while the next step would be signal processing, where ERP expression analysis and wavelet analysis is done. Now, what is wavelet analysis? You see, in a very simple term I will tell you. So, suppose you require 80 epochs or 100 epochs, that means 100 times you have to give the stimulation, so that you can get the signals at the prefrontal area, and then you average it out to get the mismatch negativity or your other biopotentials like ABR. But if you want to reduce the time of the processing, acquisition, everything, right, you go for the of course not acquisition, means once you acquire it, then so you go for the wavelet analysis. It will reduce time significantly. And the stimuli generation is done using Arduino based stimuli generation board, but we can also use other parameters, and there is a presenter software, if you remember, if you know, right. So, let us understand this one, and it has some sound at the at an interval. Okay. So, you see there are three different sounds, right. First is your AEP, then your MMN, right, and then your P300. P300 is a signal that can arrive at any time. So, there were three different stimuli that I have shown it in this particular slide. Alright, so the energized target modalities: cortical MMN, brainstem response ABR, and this is experimental protocol, where you have the band on the baby's head, right. There is a sleeping pillow, and there is the electronic module which is connected to your tablet. So, this is the way that the stimuli is provided and the corresponding the signals are acquired, right. So, what we will do, we will stop here and we will take the solution of how if you have the stimuli, if you apply the stimuli, and correspondingly if you acquire the signals, how the signals can be processed further, and what kind of band we can design for the neonatal hearing screening. So, we will take in the next class, right. I do not want to like again put too many things to you in one single sitting, that will be too difficult for for you to digest as well. So, let us meet in the next class and understand further how this process can be done. And then we will talk about the microelectrode array for not only epilepsy but also for Parkinson, to go to the next set of lectures. So, if you have any questions, again I have tried my best to answer the questions that you asked on the forum through my TA, and I hope that you continue asking, continue being curious, right, continuing being interested in learning. And some of the terms that I may not go into detail, you have a chance, you have a time to go back and see what terms has been used. A very simple terms like wavelet analysis, what is it, adaptive filtering, what is it, Kalman filtering, what is it, right. So, some of the terms that I will give it to you during the interaction, you can take it and you can use it to understand how or what exactly that term was used for during that particular slide, right. So, I will see you in the next class and continue from there. Till then, you take care.